I am Atharva Kangalkar from CSAIML A division and roll number 54. So now I am going to explain the following questions uh, based on relational database management systems. So the first question is, in a relational database model, which one of the following statements is true? The options are as given below. So the correct option is option A. Option B, if all attributes to a relation are prime attributes that are they are part of a candidate key, then the relation is in BCNF. This is because by definition a relation is in BCNF has every non-trivial functional dependency with a super key on the left side. If all the attributes are prime, then any functional dependency will be trivial or have a super key as the determinant. So the next question is, consider a so the next question is, consider a relation R A B C D E with the following three functional dependencies: A B to C, B C to D, C to E. The number of superkeys in the relation R is. So the answer is 8. And as the explanation is given below, the superkeys of the relation is given by the formula 2 raised to power total number of attributes in relation minus total number of attributes in each key. So it will be 2 raised to power minus 5 or 2 raised to power 5 minus 2, that is 2 raised to power 3 is equals to 8 keys. So the next question is, a relation RA, comma B in a relational database has 1200 tuples. The attribute A has integer values ranging from 6 to 20, and the attribute B has integer values ranging from 1 to 20. Assume that the attributes A and B are independently distributed. The number of tuples in the output of A greater than 10 union B is equals to 18 is what? So for A greater than 10, it will be 10 by 15, that is 2 by 3. For B is equals to 18, it will be 1 by 20. For A greater than 10, intersection B is equals to 18, it will be 2 into 3, 2 by 3 into 1 by 20, that is 1 by 30. So for A greater than 10, union B is equals to 18, it will be, it is given by the given above by the above terms, and it will be 41 by 60. So the estimated number of tuples will be 41 by 60 into 1200, that is 820 will be the answer. So the next question is, let the set of functional dependencies be such that f is equals to qr to s, r to p, s to q hold on a relational schema x is equals to pqrs. X is not in BCNF. Suppose x is decomposed into two schemas y and z, where y is equals to pr and z is equals to qrs. Then consider the two statements given below. The two statements are given below. So the which of the following above statements is are correct? Uh, so the answer is only second statement, that is option A is correct. So the decomposition relations Y, P, R and Z, Q, R, S satisfy the dependencies R to P and Q, R to S and S to Q respectively. Relation Y is in BCNF, but relation Z is not in BCNF because in S to QS is not a super key. All the dependencies of relation X are satisfying on relations Y and Z. So it is lossless and dependency preserving. So the next question is, consider relational table R that is in 3NF but not in BCNF. Which one of the following statements is true? So the statements are given as so the correct answer is option D. R has a non-trivial functional dependency X to A, where X is not a superkey and A is a prime attribute. A relation schema R is in 3NF. If there is no non-trivial functional dependency, the form X to A forms holds, then either X is a superkey or A is a prime attribute of R, but X is not a superkey as it is not in uh, BCNF. So A must be a prime attribute. So the next question is, which one of the uh, so the next question is, which one of the following functional dependencies hold for relations R, A, B, C and S, B, D, E, such that B to A and A to C is defined. The relation R contains 200 tuples and the relation S contains 100 tuples. What is the maximum number of tuples possible in the natural join R join S? So the correct answer is option 1, that is 100. From the given set of functional dependencies, it can be observed that B is a candidate key of R. So all 200 values of B must be unique in R. There is no functional dependency given for S. To get the maximum number of tuples in output, there can be two possibilities for S. One or 100 values of B in S are same, and there is an entry in R that matches with this value. In this case, we get 100 tuples in output. Two, all the 100 values of B in S are different, and these values are present in R also. In this case, we get 100 tuples. So the next question is, assume that in the suppliers relation above, each supplier and each street within a city has a unique name, and S names comma city forms a candidate key. No other functional dependencies are implied other than those implied by primary and condition candidate keys. Which of the following is true about the above schema? So the options are given below. So the correct answer is the schema is in BCNF. A relation is in BCNF if for every one of the dependencies x to y, at least one of the following conditions holds. X to y is a trivial functional dependency, y to x. X is a super key for schema R. Since S name comma city forms a candidate key, there is no non-trivial dependency x to y, where x is not a super key. Which one of the following is not a part of the asset properties of the database transactions? So the correct answer is deadlock freedom, as ACID stands for atomicity, consistency, isolation, and durability. So the next question is given as question 23, and these are the following options. So the correct option will be 2NF. So uh, this is the explanation. So consider the foreign transaction into banks X and Y, and the transaction are given as on the presentation. So the correct option will be option B, that is consistency. So the next question is, in a schema with attribute A, B, C, D, and E, following set of functional dependencies are given: A to B, A to C, CD to E, B to D, and E to A. So which of the following functional dependencies is not implied by the above set? So these are the given options. So explanation, the functional dependency, it is a concept that specifies the relationship between two set of attributes where one attribute determines the value of another attribute. It is denoted as x to y, where the attribute set on the left side of the arrow, x is called determinant and y is called dependent. Explanation. So closure of sets will be 1 CD to AC. So CD plus is equals to CD A B. Second, BD to CD, BD plus is equals to BD, BC to D, such that BC plus is equals to BCDEA, AC to BC, such that AC plus is equals to ACBDE. So the correct option will be option B. So the next question is, consider a schema R A B C D and the functional dependency A to B C to D. Then the decomposition of R into R1 AB and R2 CD is option. So the options are as given below. So the correct option is option C. The decomposition of schema R A B C D into R1 AB R2 CD maintains the original functional dependency A to B and C to D, but does not ensure a lossless reconstruction of the original relation when joining R1 and R2. So in simple terms, while the decompositions preserves the data in relationships, it cannot portend that merging R1 and R2 will result in the exact original dataset due to the absence of common attributes between R1 and R2. Therefore, the correct answer is C. The decomposition is dependency preserving but not lossless join. So the next question is, relation R with an associated set of functional dependencies F is decomposed into BCNF. The redundancy arising out of the functional dependencies in the resulting set of relations is, so the four are the given options. The correct answer is A. So the explanation is the redundancy arising from functional dependency in a relation decomposed into BCNF is zero. When a relational schema is in BCNF, all redundancy based on functional dependencies has been eliminated, although types of redundancy may still exist. This means that in the resulting set of relations after decomposition into BCNF, there is no redundancy due to functional dependencies. So the next question is, RABCD is a relation which of the following does not have a lossless join, dependency preserving BCNF decomposition. So given are the options. So the answer is C. Explanation: A to B, B to CD, R1 AB and R2 BCD. Uh, B is the key of second and hence decomposition is lossless. Option B, A to B, B to C, C to D, R1 AB, R2 BC, R3 CD. So B is the key of the second and C is the key of third, hence lossless. Option C, A B C, C is AD. So R1 ABC, R2 CD. Uh, C is key of second, but C to A violates BCNF condition in ABC as C is not a key. We cannot decompose our ABC further as AB to C dependency would be lost. Option D. A to BCD already is in BCF. Therefore, option C is the correct answer. So with this, we end the uh, discussion of the questions based on RDBMS here. Thank you.